Now the next topic is the power swing. So the question for this power swing, effect of swing on the performance of impedance relay, then more relay, then reactance relay. So you have to draw it. So first, the question for this power swing, what is the power swing? Then explain its effect on the operation of the distance relay. Then second is explain the effect of arc resistance and power swing on the performance of the distance relay. So you have both the questions. Then you have to write the full description for this question. So first, what is the definition for the power swing and what is the importance of this power swing? I will explain in shortly. When there is a sudden and large change in the power system. Yes, when there is a sudden and large change in the power system, that is due to the removal of the fault or sudden change in the load, there will be a change in the phase angle between induced voltage on the line. So first, the power swing is referred to the oscillation. That means power swing refer to the oscillation in active and reactive flows on the transmission line. So the transmission line between the two generating stations and the current flowing through the transmission line depends upon the phase differences. So the voltage generated two ends of the line and phase differences is equal to the rotor angle. So phase differences that means the delta and theta. So these two differences, that means the two phase differences, it is nothing but the delta at for the generating station and load end station, there is the theta. That means the induced EMF ES at an angle of del, then R at an angle of 0, sending end and the receiving end. So between the voltage at the two end of the transmission line, so the current in the system that is depending upon the particular angle. So under the steady state, as the long it is the constant phase angle are constant. So for the normal operating conditions, angles are fixed. Normal operating condition, so these angles are fixed. These angles are fixed. So the relay operate normally. Now, due to some reasons, that means the power swing occurs when the steady state condition in the power system are disturbed. Sorry, when the power swing occurs and power swing occurs when the steady state condition in a power system are disturbed. So this happens due to the sudden change in the load failures, load fault, switching action. But the power swing is a many time temporary and the system soon re-establish stability on it. But the impedance should be able to distance between the power swing condition and the fault condition. Fault condition. Now, so due to some reasons, it is nothing but when the line is disconnected from the supply due to some fault, so that the transient stability problem may be concern your system because because of this angle, that is the delta and the theta, that will oscillate the sometime until the stabilize for the new point. So it is called as the power swing or the power surges. So whenever sudden change in the load, whenever the sudden change in the load, the distributions of the so the disturbances of the fault, that is the phase angle of the rotor changes. So the rotor swings around. So the rotor swings around its position of the equilibrium due to its large inertia. So the rotor angle undergoes oscillation till the steady state as achieved. Till the steady state as achieved. एक दूसरा पॉइंट है जहाँ पे रोटर स्टेबलाइज होगा, उस पॉइंट तक आपका रोटर ऑसिलेट करता रहेगा. It is called as the power swing. So current in the system also undergoes the oscillation due to this impedance realization. Realize the relay surge condition is called as the power swing system of the power swing system. Now, now consider the section of the power system as shown in the figure. So this is the sending end voltage and this is the receiving end voltage. There are the two voltages generated by the alternator 1 and 2. So during the power swing, this induced EMF remains maintained the same magnitude, and but there the phase angle changes. But the phase angle will be the changes. Suppose the phase angle delta and E1. Suppose the phase angle delta and E1 leads to E2. E1 is leads to E2. E1 leads to E2. E2 by an angle by angle delta by angle delta. So this angle delta it varies till effect the power swing on the disturbances is damped. Okay. So this impedance is this angle is varies till effect of the power swing or disturbances is damped. Now the Z is the impedance. The Z is the impedance of the rotor. Impedance of the rotor. So you will get there is the and VR and this is the IR. So it is nothing but there is a ZR. Okay. So this ZR is nothing but this is the impedance seen by the relay during the power swing. And this VR is the voltage applied to relay and this is the current through the relay. So it can be very derived that we will get the K is equals to, we will get the K is equals to, just wait, yes, pen, yes. So ZR is the impedance of the relay and VR and IR is the voltage applied to the relay coil or the current coil. So it can be derived as ZR, it is nothing but it can be derived at it is nothing but the impedance seen by the relay during the power swing. So you will get K is equals to E1 upon E2. E1 upon E2. So the ZR is the total impedances of the circuit. That means Z1, ZL. That means this is the Z1, this is the ZL, and this is the Z2. ZL. It is nothing but the ZS plus ZL plus ZR. So, so the ZR is the function of the delta. So ZR is the function of the delta. It is the function of the delta. So from so from we can draw the swing impedances locus in the RX diagram with the K as a parameter and the delta as a variable, so that we get ZR is equals to F bracket delta. So the center of this circle slides on the straight line and a straight line and collinear with the impedances ZT. That means you have to draw the one circle. You have to draw the one circle. That means it is look like that. It is nothing but this. In this diagram, there are showing the directional relay, more relay, reactance relay, and the impedance relay. But you have to only draw when the effect of power swing on the performance is impedances. So you have to draw for the impedances. That means when the there are some effects. There are some effects. So which effects? That means the power swing is experienced by the relay appear like a fault, and there may be the maloperation of the relay and due to the particular of the power swing. So the locus of the power swing indicates the impedance relay. That means it indicates the impedance relay, and it sends the impedance sent by the relay because of the power swing. So the locus seen by the relay alone. Now there is the problem of the inductance. And so and what is the and so this is the particular locus of the power swing indicates what is the impedance seen by the relay, particularly of the power swing of the locus of the power system of them. So it will comes and touch in particular regions, in particular regions. So it will come because the relay it is in the mal operation. So the point where interacting, this is called as the electrical center. I will draw here the RX diagram. It is nothing but this is the diagram. So this is the circle. This is the R. Sorry, this is the RX diagram. There is the minus R. There is the plus R. This is the X. There is the minus X. Okay. Now, so the impedance by the relay of the power swing, impedance of the power swing. So the locus of the power system are the uh, locus of the particular region. So it will comes and touch into the particular regions, and so it will mal operations. So the point where say intercepting this it is called as the electrical circuit network. That means you have to draw one line, and it is called no no you have to draw like this. This is the RX diagram. Yes. And this point is called as the electrical center point. Yes. Electrical center point of the transmission line. Whatever importance of the transmission line, that is Z2 impedance of A to B. Yes. This is the impedance of A to B. So the impedance of the A to B, you have to add the importance of the uh, impedance of the generator, then block side, backside. So this is nothing but ZS and the ZR. So locus will pass through the electrical center and pass through the electrical center. So this is the electrical center. Okay, electrical center. The line is particular center line and importance seen by the main minimum electrical center point is there. So the particular this operation, uh, mal operation is more. Mal operation is more, and so the because of this area is covered maximum. So this area is less than. So the effect of power system is also less. So the important impedance relay is occupied more area, so it is very much mal operation of the power swing. Now, during the power swing, it is realized by seeing that the relay's combination is a source, then impedance, and behind the relay, transmission line is the important. Now, important source at the remote end, so the trip it measures value of the external